Here we have two controller boards for dentist chairs that came in for repair, and both of them are apparently suffering from the same issue. I never worked on those boards before, and those boards are discontinued. Customer cannot buy them anymore, and dentist chairs, they go between $5,000 to $18,000. It depends on which chair. Let's read what the customer wrote. Referral, I'm a YouTube subscriber, or I'm a subscriber on YouTube. I'm sending you two controller boards for Kavo Environment 2004 model dentist chairs. Both have the same issue and were installed to see if we can fix the chair not moving problem. In the same chair, which apparently has a short and burnt a small controller or the connection on the boards. These chairs go up, down, front, back when the pedal is pressed. Signal goes to the board and it activates corresponding solenoids for each hydraulic line. You can see a small blackened area on the same place on both boards. These chairs are discontinued and parts not available. We like to fix these boards as spares. For other similar chairs, we will include pictures with the package. So the customer is not fixing the boards to fix the broken chairs that they have, but these are spares. I like that sentence. I do not know what's involved. We're gonna put the time and see if we can figure it out. Now, looking at the first board, one of the two boards, I do see a burned fuse, like the customer said. It looks burned. And I do see a burn mark right under the connector. Possibly damaged traces. And I do not know what those components are. We're gonna have to see and check if they are good. And if we look at the second board, the fuse looks good. I mean, we did not measure it. I did not measure it yet, but I do not see any burn mark on that fuse. I do, however, see a burn mark under the connector in the same exact position. Okay, let's start with the one with the good fuse, and we'll take it from there. Now, first thing first, we're gonna check the fuse, and that fuse is protected. It has rubber all around. We're gonna have to measure it from the bottom. Okay, I'm using the NorthridgeFix microscope, and just look at the clarity. You can even see the texture of the motherboard. If we check meter in continuity mode, we're gonna check from here to here, and the fuse is good. Let's check the second board. The fuse looks burned, but we have to confirm, right? And the fuse is blown, yes. Okay. Let's stick with the board that has a good fuse. Even though we're not gonna be able to test the board afterwards, but I do not want to have to deal with the fuse, remove the overcoat on the fuse, replace it. So we're gonna start with this one, and then we can work on the second board. Now, those are possibly triacs. And we're gonna have to measure them. But what's going on under the connector, nobody knows actually. Nobody knows what's going on under the connector. If we look here, I'll put the light up, overexpose the image. I do not see a burn mark here on the board. I do not see a burn mark here on the board. I do, however, see a burn mark here. I mean, even the connector is discolored. It's a nasty burn. And look at this. We see damage. I do not know if this is making a connection or if the line is broken. You know what? Let's use our multimeter in diode mode. And we're gonna check. We're gonna check from here to here, and the line is broken. Assuming this line is going to this pin. I do not know that yet, but it looks like it's going to this pin. What about here? No. This one should be going here, and yes. So we have a problem with this line. Meter in continuity mode, still. Let me measure from here to here. Let me go to diode mode, okay? So you can hear the beep. If we measure from here to here, 0.19 voltage drop. I have my red probe on the left and black one on the right. If we flip, 0.19, okay? If we measure here, 0.20, more or less like the first one. If we measure here, 0.16, it's different. And if we measure here, 0.18. All right, let's measure from here to here. I'm reading OL. Measure from here to here. I'm reading OL. 0.20. Short, that short. What about this one? Short. And this one is reading 0.17. So on this one we have a short on the first pin, bottom left, and on this one we have a short on bottom right, or vice versa. This one bottom left and this one bottom right. Okay, what about this one? OL and OL. That's the normal reading. Let's check the second board just to compare readings. Check from here to here. We have OL. We have OL. Check the second one. We have OL. And we have OL. Okay. What did the second one read on this? We had a reading of 0.2, and that's not good. It should read OL. And on the second pin, we have a short. But on this one, it looks good. OL reading and OL reading. Check this one. And we have a short from here to here. So this component is bad. And finally, if we measure this one, OL and OL. Let me go to the board with the good fuse. We have a faulty component here, and we have a faulty component here. Okay, so we're gonna have to replace those two components. This one is reading OL, right? OL, 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 OL. So this one is faulty, and this one is faulty, both of them. And this one is reading OL, OL. So what we can do, we'll attempt to fix one board. I do not have those components. I'm gonna have to order them. So we can use components from the other board to fix this one and replace those two components. We're gonna check to make sure the connector is good. We're gonna desolder the connector, check the wires under. And what we can also do is meter in resistance mode. Let's make sure those resistors are good. Okay, 27.8 ohms. 27.6 ohms, close enough. That's the tolerance. 27.7 ohms. 27.7 ohms. And 27.9 ohms. Okay, very good. What else? .33 reading. This is OL. And this is OL. Let me check the second one. Okay, 28.2 ohm reading. We have OL. And we have OL. Okay. So first thing first, let's desolder the connector and see what's under. And how do we desolder the connector? How many pins is the connector? 1, 2, 3, 4, and then times 3, 12 pins. The connector is 12 pins. We're gonna have to use low melt solder. Now we can do this two ways. We can apply hot air and remove the connector, or we can apply low melt solder, which is the preferred way, so we do not expose the board to a lot of heat. Right now the board is gonna wobble all over the place because the board is sitting on this transformer here, so it's gonna wobble. Okay, if the camera went out of focus, if the microscope went out of focus, you know why. Maybe I can put something under the board so we can make it as stable as possible. And we're gonna apply NF.flux. Such an amazing flux. I went over this in the last two videos, and I mentioned how this flux is magic. Just like low melt solder, this flux is magic. A lot of people are trying to categorize this flux. Is it mechanic? Is it MG Chemicals? Is it Amoe? Is it... We sold over 1,200 syringes in 2 days. People climbed up the ladder, and others are still on step 1 of the ladder thinking, who came first, the egg or the chicken? What is that flux that you are using? It's called NF.flux. Our flux is gooey. It has texture to it, and it lasts a long time on the board. It does not burn easy. It does not smell. It smokes much less than rosin flux. And I mentioned this. I do not want to keep going over it, but you're not going to get anything better than this. RoHS 3 compliant and JSCD 0048 compliant. So the flux is human safe, environment safe, and it's safe to be used on circuit boards. Fume extractor on. So we're gonna grab a stick of low melt solder. And what does low melt solder do? It melts at a very low temperature. We're gonna mix it along with unleaded solder on the board, and the combination is gonna be a lower temperature. It will take a lower temperature to remove that connector, rather than applying 450 degrees Celsius on the board to remove that connector and possibly damaging this hard to find board. We're gonna do it the safe way, and we're gonna use low melt solder. You see how that pin is moving? We're gonna do the same thing here. We're gonna do the same here. The pin is moving. And whatever we are using in this video, low melt solder, the NF.flux, soldering station, hot air station, thermal camera, braid wick, tweezers, you can buy directly off our site, one-stop shop. We're not just selling for the sake of selling and making money, that's part of it. But whatever tools we sell, we use them on our bench. We believe in them. They work. You do not need to do your research. We did that for you. Look at the clarity on this NorthridgeFix microscope. You're not gonna find anything better. I'm not even using the anti-glare light. If you wanna see the board under the anti-glare light, then you will see this. No glare from the flux. Just pure solder joints and the pins. Okay, so we need to apply heat uniformly on all the pins, and we should be able to remove the connector from bottom of the board. Let me put the ring light back on because I'm extending the board beyond my bench. I have my microscope camera extended. Now we're gonna apply hot air, and I'm gonna grab the connector from the bottom with this 90-degree plier, which you can also find on our site. Okay, the pins are moving and the connector is out. Right here. And tell me low melt solder is not magic. So let's take a look at the connector. I mean, we do see a burn mark on the connector, but it's not a big deal. As long as the pins are good. The pins are nice and even. And we should be good. Maybe we can test the pin from here all the way to the bottom. Make sure it has a connection. We do not need to worry about the rest of the pins. They all look nice and clean. So which pin is it? It's pin number 2 from the left. Okay, so we're gonna measure from here to here. Meter in diode mode. And we have a 0 reading. Meter in ohms mode. And we should have a 0 ohm reading. And we do. Okay. The connector is good. We do not need to replace the connector. Let's put it on the side. Focus on the board. And look at the mess that we see here. We did measure from the pin of the connector all the way here. And we did not get a reading. So meter in diode mode. Measure from here. You see how low melt is still soft? Look at this. It's brittle. Okay? So the line is not making a connection. Look at this. If I measure from here to here, yes, we do have a connection, but we do not have a connection from here to here. The line is broken. The line is broken somewhere. Let's clean the holes. Now we're gonna have to charge the customer for 1 roll of wick. Right? No, it's part of the repair cost. But you will need a lot of wick to get rid of solder from the holes. Now I think first thing first, we can replace the faulty 3X that we have here. Just a tiny bit of flux. We do not really need to apply flux when desoldering, but it does help with the flow of solder. And that's what happens when you have good flux. Look at the flow of solder. Even when desoldering. Let's grab 2 good components from the donor or from the second board. Now I'm not going to use flux, and let's see the difference. You see? Look at the flow of solder. It's different when you use flux. All right, and we're all good. See what happens when you use good flux? It remains on the board. It doesn't evaporate as quick. It doesn't burn. It doesn't smell. And you'll have perfect joints every time. So measure from here to here. Oh well. Oh well. Oh well. Oh well. Oh well. And oh well. Very nice. Let's measure this one too. You know, I forgot which ones we replaced. That's how good the soldering is. Oh well and oh well. That problem is fixed. Now we need to fix the trace problem. Now we're going to use a grinding pen. Grind that trace and look at this. The battery is out. The battery is out. I'm just squeezing whatever power is left. I'm not seeing the trace. Where is that trace? Look at this. I'm not seeing that trace. What is going on? Where's that trace? So if I flip the board, we do not see any traces on the back. There's one on the side here. It's like, look at me, I'm here, but I'm not there. We can still run a wire from here to here. Copper is exposed here. And I do not know what's going on here. But I'm not able to find that line. Why? I don't know. We did not overgrind. Look. Weird. It's like the copper line totally evaporated. Where is it? If that board wanna play games, no problem. Let's solder that connector back and then we can run the wire. Right, so the connector is in. Now we're gonna have to solder it from the back. Let's make sure all the pins are in. Very nice. NF.flux. So good you can eat it, right? No, do not eat it. It's not edible. When we make it edible, I'll announce it. Now I just want to secure the connector from a pin or two so I can let go of the board, because right now I'm pressing the connector down on my bench. I want a flush connection. And just want to solder one more joint and then I can let go. Okay. Now in a situation like this, I can use the Barlow lens so we can see more of the board, but I'm okay. And look at that flux. Look at how it stays on the board. Okay, the board is wobbling up and down. What can you do? Almost done. Okay. Because it's a big board, it's hard to see under the microscope. But that's the connector right here, 12 pins. We replaced two components in front of the connector, and now we're gonna have to restore that broken trace. If I run a wire from the component all the way to back of the board to the second pin on the back, that will work. I can even drill the board because I do not see any wires. Yeah. I mean, what I can do also is I can drill the board. I do not know if you can see it, but we do not have, if we drill right here, the board is empty. We do not have any traces running from this side right here. Okay, so that's another option. Because right now, even if we ran the wire under the connector and then we put the connector over the wire, we do not have control over how solid that wire is, or if it's gonna give out in the future if you unplug. Let's make a long-lasting fix. The wire did burn on this board, it burned on the other board, so maybe we'll make a more solid solution. All right, so we do have the hole right here, nice and clean. Right there. I mean, if you ever done electrical work, you know how conduits are bent. And we are done. Now we're gonna have to do it from the back. And the back we're gonna have to do pin number 2. right? So the wire, see the yellow wire? It's running from the first pin of the component to that second pin of the connector. Okay? We're gonna invoice and mail it back to the customer, and we're gonna do the same thing for the other board, but of course we have to order the parts, we have to order the fuse, and we'll do exactly the same thing that we did in this video. I hope you enjoyed the video. Let me know what you think, leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.
Better than factory.